as we are also part of this hub, Valencia. 3D printing technology will be treated in detail in the next slot. So I'm just going to show you the 3 different systems for 3D printing we have available at ProFactor. They are different with respect to the 3D printing technology they are based on, the materials they use, and the resolution and finishing of the quality of the printed part one can get from them. We have desktop 3D printing from the company Ultimaker, which works with the technology FFF, which stands for Fused Filament Fabrications. And yeah, it's based on filament-based 3D printing technology. We have also a desktop printer working with the technology SLA, which stands for stereolithography. And finally, the most powerful technology we have in-house with respect to quality of the finishing and also resolution is PolyJet, which will be introduced by Leo and Naomi in the next slot. Yeah, on the bottom of the slide, you can see some examples of 3D printed parts by Elizabeth Jayot, one of the artists of the first CAL, who was working at ProFactor. So as I said, there is a time in the next slot to discuss the different technologies, but keep in mind that you can make use of this 3D printed technology to complement your projects when you are applying for Hub Valencia. So that is all from my side. I think we are behind the time. Leo?
Just a little. Thanks all for showing us the nice technologies. As Elena mentioned, we are slightly behind schedule. So I would say we continue with the session from 2D to 3D. In the meanwhile, please post your questions in the Q&A part of this webinar. Alternative to the chat function, use the chat function to ask your questions. And in the next session, we will try to answer all of them. Okay, with this, let me continue with the 2D to 3D session. For this, I want to introduce also myself. I missed that in the beginning, so I'm sorry for that. And also want to introduce Naomi and Guillaume in this session. First, some words to myself. As you see, my name is Leo Schranshofer. I'm also from ProFactor, as well as Elena, and I'm working on the PolyJet technology together with Stratasys, and also kind of manage the technical progress in the Re-FREAM project itself. So these are some words to myself. Naomi, some words to you.
Hi, I'm Naomi Kempfer. I'm creative director for Stratasys Ltd, one of the leading companies in the field of 3D printing, manufacturer of 3D printing technology. And in the Re-FREAM project, we are going to focus on 3D printing on textiles for the fashion market.
Thanks, Naomi. Guillaume?
And hello, everyone. My name is Guillaume Clément. I am working as an R&D engineer at the company Haratech GmbH. Yeah, and we are working on different kinds of 3D printing, but also body scanning, different kinds of 3D scannings, and also using different softwares to generate and simulate, mostly generate 3D shapes.
Thanks, Guillaume. With this, let me briefly introduce what the PolyJet technology is about, since this is one of the key aspects and one of the key technologies provided in the hub Linz. For those of you who are not familiar with this technology or slightly familiar, as said, let me just briefly introduce it to you. PolyJet using inkjet technology to build up multi-material objects from layer to layer. So what you do basically is apply one layer of a polymerizable resin, polymerize it, and deposit then the next one. This happens quite fast. There are a lot of videos present on YouTube or on social media or wherever. Undermine this, you also see some links. I will then post it also to the chat function, where you can have follow-up information on that. But the main benefits of PolyJet regarding or compared to other 3D printing technologies like FFF, SLA, or SLS is that you have indeed multi-material printing possible at the same time, not just after each other, but also in plane. So even within the first layer. So speaking of multiple colors, but also multiple properties of the material, not just color appearance, but also, let's say, mechanical properties. Think of soft and stiff material in one object. Also, the resolution is a big benefit of the PolyJet technology, since as said, it's based on inkjet technology. So the resolution is determined by the printheads used, and we achieve a high resolution down to, let's say, 20 micrometer resolution, and reflecting also the quality with this. Within Re-FREAM, we develop, and what we offer is printing on fabrics and textiles, since this is one of the novelties where we joined forces within Re-FREAM and seeking out the artists and designer to challenge us and also to challenge the artists. Naomi, can you support me here with some nice examples on
Yes.
what's possible with PolyJet technology?
Sure, I'll be happy to do so. Leo, can I share my screen?
Of course you can.
All right, so let me select here something. Can you see this?
Yes.
Okay, let me see how I start the presentation. Okay, so first of all, again, about Stratasys, we work with artists, designers, architects, and fashion designers globally since more than 6 years. Our aim is to enhance creative collaboration with our technology, and that's also the aim of the Re-FREAM collaboration funded by the European Commission. So our focus is this time 3D printing on fashion, on textiles for the fashion market. My background is, of course, I work as creative director for Stratasys, responsible for these creative collaborations within the company. And my aim is to enhance the creativity of our partners and to challenge our in-house technology for the creative market, to see how we can evolve our applications for the creative market around the world. In the last few years, we're looking at fashion. Now, fashion is everything that is constructed around the body. It could be accessories, it could be rings, earrings, bags, shoes, etc., etc. Here are just a few examples. Here we see Neri Oxman, external digestive system to allow us to manage different atmospheres beyond the global condition of planet Earth. We see the molecule shoes by Francis Bitonti, demonstrating in 2014 the first full 3D color printing. We see here Noah Raviv, a beautiful demonstration of architectural meets fashion. 3S4 showing the pangolin dress and the harmonograph dress, elaborating how organic algorithm and our soft materials, the agilus materials, how they can fit the construction and composition on top of a human body. Just to elaborate, we usually feature all these projects in museums also around the world. This one was shown at the Cooper Hewitt Museum in New York City recently. This is a project in collaboration with Iris van Herp, and this is the earliest project we did in direct 3D printing on textile. As you can see, the different lamelles are mounted in the print itself on the textile matrix. Last year, we launched 2 projects under the collection of the Chromorpho, speaking about chromatics and the morphology, the movement that is enabled thanks to the mounting textile. The 3D printed hairs on top of the textile generate a full color movement depicted by this wonderful dress. And this Thursday, we will demonstrate and show the new collaboration with Julia Kerner that was selected to this year's Re-FREAM project. Those who will follow us will be able to see Julia's next generation dress following this one live. This was also part of our Chromorpho collection, Greta Otto in collaboration with 3S4, using the lenticular principle, also completely 3D printed with polyjet technology on textile. Each eye drop in this dress contains graphic data that has been seen in different colors depending on the angle of the vision. Here we show and demonstrate also 3D printing on leather. This is a project by Samson Safran, bringing a contemporary view on Bedouin patterns. And Thursday, we will also see a new project in collaboration with Ganit Goldstein. This is going to be a very exciting release. I invite you all to participate Thursday. And if you are not able to participate, follow on the Instagram channel of the Re-FREAM project. We will be sure to show you all the fantastic photography of this new special project that will be released. So Ganit, as each designer that will participate with us, went through the whole process from concept, understanding what you would like to 3D print on textile, together with the Profacto team, Haratech team, and with Stratasys team. We all supported her on the mechanisms, the creative choices, and the mechanical solutions to enable this project. All 3D printed with Stratasys PolyJet printer and finalized in these last few days. So that is just a little teaser for those who want to participate with us in this 3D printing on textiles project. I recommend also to follow the presentations this Thursday, where we will release the final results of Julia Kerner and Ganit Goldstein.
Thank you, Naomi, and also thanking you for the advertisement to our events this week. Thank you for that, Naomi. Also for showing these nice pictures, what is PolyJet capable of to the current state. Guillaume, please also show what is possible together with Haratech.
Sure. Then I would share my screen.
Maybe
possible.
also some words to yourself.
Yeah, I think so.
Some additional ones.
Starting some additional one, yeah. So what I'm gonna present now is all the technologies that we have available at Haratech in Linz, which are applicable potentially for Re-FREAM, maybe not, but we have a larger panel that we used in the first run, for example. This is way more technical and industrial than what we saw with Stratasys before, for example, because we are not only working with fashions, but in many different fields, which makes actually the co-working interesting, because then we're really mixing worlds together, the fashion on the one side and the industry on the other side, and the more technical side, so that we are eager to open up. And yeah, So to give you a brief overview of what I will be presenting in the few minutes, so 3D printing, FFF, also body scanning that we have, and other kinds of 3D scanning, laser cutting and etching, vacuum casting technologies, injection molding, which are for bigger series, but why not? And eventually I will also present the design software solution that we have here at Haratech and also at the Fashion and Technology Department of the Linz University of Arts. Yeah, Sander Hofstee was supposed to be with us today, but unfortunately he cannot join. So I will present these few solutions for him. A few words to the company Haratech. So we are in Linz in Austria, 40 kilometers away from Profactor. And we do conception as well as production from plastic parts in any kind, any application fields, transport industry, so aircraft and cars, but also fashion, sports, medicine, etc., with 3D printing and other technologies, as you will see. And each one of them could be useful for any kind of fashion creation. We just have to open up and discuss and interact and co-create together. So the first and most known one is the 3D printing with filaments, so fused filament fabrication, where you can see we can print different filament at the same time, different colors to achieve different shapes. We have different kinds of printers here where we can test many shapes and many techniques. For example, the Yokai team, which is also a team of artists who got selected for the first Re-FREAM round, they will have their presentation on Wednesday. For them, we have been trying also 3D printing on fabric, on stretched fabric, for example, which is a new kind of thing that we tested together. But not only the different techniques, we can try also many different materials, different colors, different hardnesses, and also more, for example, if you want to work more with renewable or bio-based resources, on the right side, you can see baby Groot that has been 3D printed with wood fiber fields polymer, for example. And again, the possibilities are numerous, plethorous. We just have to try it out. Nothing is excluded. We have lately acquired a new kind of 3D printer also, the ProJet CJP. So it's inkjet printer with filler materials, so with on a powder, which is not only inkjet like Stratasys PolyJets. It enables to print, for example, statues in full color also, maybe not exactly with the same resolution, but that's also a possibility that we have in-house where we can work on it together. And you can couple it with the body scanning. This device, you can see the person on the left standing on the platform, and in 30 seconds, the scanner heads turn around the person and give a full body color 3D scan, which is precise, plus minus, I think 5 millimeters or even less, which is fairly precise enough to then design garments directly on this 3D mannequin, which is then opening complete new ways for fashion design. But you can then do many different things with that and scan not only people, but many other kind of objects. And just to give you another overview, we have other kind of 3D scannings, which are also much more precise, and you can scan up to any size since the scanner is mobile. You can the statue on the left is something like 15 centimeters high, on the right is 1.5 meters high, and this is not the biggest thing we could scan. So really giving a lot of possibilities. That would be for 3D scanning. We have also a laser cutting machine, which enables to cut, but also to engrave. So on the left side, you see that several materials have been etched or cut and then glued together or assembled together with a high precision. We can etch with different depths and different materials. So wood, but also plastic, thin metal sheets, and other things. And on the right side, you can see that just this wooden board has been etched point by point to create this pattern in the end. We can also cut fabric, sorry, I forgot to mention, which is very interesting for the Re-FREAM project. Yeah, and we sure have not explored all the possibility of this machine so far. Another bit more industrial technology is the vacuum casting mode. So we 3D print a model, then cast a silicon mold around it. When it's hardened, we cut the mold in half, open it, and cast a new part in the middle. This allows a very nice precision, very nice surface finish if we want to produce 20 to 50 pieces in a row, if not more. And then we have access to a wide range of materials with different transparencies, flexibilities, colors, and so on and so forth. Yeah, with a high detail fidelity. And going into the big industrial mold, injection molding, of course, is less used in fashion because it requires a big mold and it's for big series, enables to make many different kinds of plastic parts. But we in Heritage were also working on on the right picture. You see that the cavity has been 3D printed and then inserted into a steel mold. So that opens up new possibility because we are much more flexible for the shape of the mold. Of the cavity, sorry, we can modify it quite easily and try new things out. Why not have inserts? Why not fabric inserts inside the mold? So we can really play around with the machines. We have the facilities and the know-how and we want also to try new things out. That would have been for injection molding. After the hardware side, we are going to the software side. So to begin with, we have some parametric design software like PTC Creo, NX, or Fusion 360 from Autodesk, which are similar also to SolidWorks and CATIA. Those are more engineering software, but also not to forget completely because they have some interesting interests, but more in the design and architectural design creation mode. We have, for example, Rhino with the Grasshopper plugin, which is amazingly useful to create some parametric pattern, but still very organic designs. So this has been made by Sander Hofstee from the Fashion and Technology section of the University of Arts in Linz. You can see at the right side how he created these 3D objects, playing with all these parameters that you can see in the small window. On the left side, then we have the part 3D printed with a lot of different color shapes and shapes in itself. So it enables really sky's the limit in terms of creative possibility. And also interesting for working on facet models. So STL, we have the software's Mesh Mixer and ZBrush, which give a lot of possibilities to really model on the computer directly, like a sculpture. Some other software that Fashion and Technology has is the rendering software for keyshots, which enables to have nice visuals. Also, some simulation software like Assist, and most importantly, CLO. You can see on the right side that CLO enables to simulate in real time how fabric behaves, the rigidity of seam lines, the flexibility of some piece of cloth, of fabric that you can sew together, and you can adapt the pattern, the 2D pattern and 3D shape on the display will adapt automatically. So you can also simulate movements and many different configurations. Very exciting software. And so that would be it for this short and quick presentation of what we have in Linz. Yeah, if you have questions, please feel free to ask them in the Q&A. And yeah, also looking forward for the presentations of the artists we have been accompanying these last months. So on Wednesday and Thursday, we have the Yokai team, Ganit Goldstein, and Julia Körner also. So thank you for your attention and see you soon, hopefully.
Thank you, Guillaume, for the nice overview of the Heritage capabilities. As Guillaume mentioned already, please ask your questions in the Q&A part, which is now covering first the Valencia and the Hub Linz topic. So all the technologies you heard before, now is the time to answer the questions. You can either way do it via the Q&A or via the chat function to the webinar. In the meanwhile, maybe some nice stories, storytelling for the Re-FREAM project. But our first question by Florence Post, I hope I pronounced it correctly, is about the, I assume a question to Guillaume, is do you try to inject plastic for really tiny pieces?
Depends what we call tiny pieces, but let's say part that are big, like small up to a few millimeters in length, that is completely doable, yes. And for even smaller parts with very tiny details, then we need the special equipment, other specialized injection molding machine. But with details up to 0.5 millimeter in thickness, this is doable on the machines we have in-house, yeah. If that answers your question. And also, yeah, during the injection molding process or afterwards, we can also put inserts, so flexible, rigid inserts, metallic one fabrics, buttons, whatsoever. Like, yeah, just have to try it out.
Maybe related also to the question, we've tried to inject plastic for really tiny pieces. Maybe some words from you, Naomi, on the resolution capabilities of PolyJet, and maybe then also follow up a question also to you, Guillaume, on the capabilities of FFF printing to pick this up. What kind of resolution can be achieved? What's your best practice? What's your best experience? I mean, not just the technical limits, but what works best in your opinion?
Maybe let's start a step backwards. Technically speaking, everything that can be translated to a data file and can be exported for a print file is feasible for print. The question is afterwards, of course, how strong it is to survive. So we are working with polymers, and when we print a hair-thin structure, then we have to understand that it is a hair-thin structure. So most likely after we print it, we still need to manipulate it. So the consideration is not as much as the resolution, but really how are you going to manipulate it? So if we have a hair-thin structure that is joined to a textile, or that is supported, let's say, within a glass structure or another composition, then you can make this very thin synthetic hair stand out. So at the end of the day, since we really print in a resolution of 8 to 16 micron, everything is feasible in any color and in any consistency. The understanding has to be more, what are the mechanics, what is the strain that the geometries have to withstand, in which combination and in which context are these structures foreseen. But technically speaking, since we are printing such tiny droplets, one has to understand that the possibilities are endless. Do we have more questions?
Or maybe to complete regarding FFF printing, I would like to mention that the major advantage of this technology is the wide panel of materials that we can add, because basically any material that we can use for the injection molding technology, for example, in that case we have a lot of researches because it's the most used plastics engineering process. Then we can use all this material for 3D printing, basically for FFF 3D printing. So we have a whole variety to use with field materials, with wood fibers and other examples, carbon fibers also. When it comes to precision, then it's maybe better to go with another printing technology like PolyJet or maybe SLA or stereolithography, because then we can have thinner details. So it's also a question to have in mind, what is the biggest constraint or the number one priority that we have? We want absolutely this kind of material precisely, and that in that case I cannot use every kind of printer with that, or do I want to have a very detailed view? Do I want to have a full color model? And in that case, it will lead automatically to this one or this one 3D printing process. But regarding the resolution of the FFF, then in the Z-axis, so upwards, then we can go in layers of a few hundreds of a millimeter. But in the width and length axis, then it's a bit more difficult, because you always have to consider the thickness of the filament that has been extruded. That is maybe minimum 0.5 millimeter, and I don't think we have tried it that thin yet, because as Naomi mentioned already, you have to think also not the printing itself, but the manipulation afterwards, which brings some more difficulties.
Thanks, Guillaume. Thanks, Naomi. Maybe to add here also a question related resolution to follow up, maybe also the question from Florence. I hope you don't mind. Question to Carmina and Belen in this. When you have added features on the fabric, which aspect ratio, which feature size you can easily live with, or is there any limitation on that, that your technology does not harm at least the structure? So might there be a bottleneck here when thinking about printing something on a fabric, or have a structure on the fabric and place it on your machine? Will the structures survive, or will they be affected to a certain extent? Maybe you can elaborate here a little.
Leo, do you mean the structure about the
3D printed structure, when there is a 3D printing structure?
For the dyeing that we have done?
Yes.
Okay, we haven't done many trials so far. We have just tried to very simple shapes. And for sure, we need to try which is the effect on the more complicated structures. What we have tried till now, it remains exactly as before dyeing. But of course, we are having some mechanical action during the dyeing process, as the same as you have seen with the garments that are tumbling. So we don't know if for more complicated shapes will be affected or not for this mechanical action.
Thank you.
But not all materials are dyeable. So we have tried, I think, Elena 3 types, and only one of them was dyed.
And the feature size that these pyramids were at least 1 centimeter height, and they survived the treatment without any problem with undercuts. So
thanks. Any further questions from the audience so far? Please feel free to ask. Now is the chance. Maybe some best practice stories from our panelists. Always good when I'm starting to ask to tell a story, there is a question popping in. Nice. Or not. But regarding panelists, regarding best practice story of our panelists, Agnes, can you elaborate a little on your experience on the first round on the co-creation aspect regarding also technology development? What was your best practice experience so far when the artist approached EMPA?
Well, I work on quite a few projects. These were completely different experiences depending on a project. One example which I can mention right now is a collaboration with Jeff Montes on his project Marinero, where he developed materials or fibers together with other partners that were reacting with moisture, and they were wrinkling and curling and changing the shape of the fabric that was made out of this material. At ENBA, we were looking at the visualization of this change of the fabric on the body using our virtual environment software in this case, and as well as we tested it in real life, exposing these garments to a thermal mannequin that was sweating. So the moisture was delivered and we could really see how the garment was changing shape, life on the body of the mannequin as it would be on the human body if worn during activity involving sweating. So this was really quite amazing experience on the level of doing something that we don't do every day in our institution. So seeing something really happening physically, and not only delivering some numbers that we see they are different, but here you could see really by naked eye that the dress was fully changing, and we could simulate it as well, and it was very similar to what we've seen. So that was actually very encouraging. On the level of simply working with artists, this was also quite an interesting experience. We as scientists, I mean, I'm talking now for a scientific community, we are trained to be very strict, very precise, well structured and organized. And when talking to artists, they are really talking like they were daydreaming all the time. So this is a combination of two, or actually clash of two words that, yeah, we also do not experience every day. So it was quite interesting how I had to make compromises from my structured way of thinking to pick up some interesting ideas from Jeff ideas, and he also learned from me, I guess, that yeah, not only daydreaming, but if you want to have a commercial product, you also have to have a little bit hard facts on the table and a structured approach how to analyze and assess your creative dresses or creative endeavors.
Thanks, Agnes. In the meanwhile, a question popped up in how did the hubs experience COVID restrictions enforced by the EU governments? Did it impact the collaboration with the artists? For example, was any artist unable to travel? How do you foresee the coming year in those terms? Are there any remote co-creation preparations experiences? Of course, with the COVID-19 situation, we faced something that was obviously unforeseen, and of course we mitigated it in this way. What we mitigated was that, or in that way, that we limited this co-creation aspect we defined in the beginning, in the first round, to be physically present in the hubs with a certain amount of spent time in the project to mitigate it as good as possible to have the co-creation still valid, and if it's online presence and online tutorials, online working together, then it was that the case. So it was then limited to go that each partner does their own in their labs if possible, if they were not affected by any shutdown procedures. We also mitigated in that way that we try to prolongate the projects to a certain extent, and most or all of the projects are now have now ended in the meanwhile we had so far. The plans for the future are based on that. We are aware of that and look at the growing numbers and always count in what the governments are telling us. So this we take into account. I hope this answers the question a little bit. There is also a follow-up question coming from Florence on our previous question. The question is, I see now polyamide 6.6 recyclable for 3D printing, but I don't see results with dyeing process. Does somebody have experience with it? A question to Carmina and Belen, obviously. Could you elaborate on this, please?
Well, really, the trials that we were commenting some minutes ago were done on polyamide. So there is a good chance to dye recyclable polyamide 6.6 to be dyed through nebulization system that has the advantage of being a very sustainable way of dyeing any substrate, including the 3D. Yes. But we haven't done a huge amount of tests, but we saw that it is dyeable material through nebulization system. So I think that it opens a way of processing also this type of material.
I hope this answers your question. We continue on being a little bit behind schedule, so this seems to be consistent to a certain extent. Let's proceed to Hub Berlin, and here I want to hand over to Robin and Christian Diels, who is also obviously in the line. Please start the webcam, show yourself, introduce yourself, and show us some amazing, let's say, printed electronic magic.
Hi guys, good afternoon. Robin, I would like to start.
Yeah, perfect, go ahead.
Okay, yeah, welcome everyone to this afternoon session. I hope you have a coffee or get some light in. Wake up. So, yeah, my name is Christian Diels. I work here at the Fraunhofer Institute for Reliability and Microintegration in Berlin. And I was involved also in the previous 3 artist challenges from the first round. Here at Fraunhofer, I'm working on the stretchable and textile integrated electronic systems. Maybe just 1 or 2 words to the Fraunhofer Institute. We are located in Berlin, Dresden, and Cottbus, and we conduct research in the fields of microelectronics. And we can provide expertise and know-how through the whole entire process chain of microelectronics. So starting from wafers until the final system. I have been working here for almost 13 years, and my background is microsystem technology. I was really interested in e-textiles or smart textiles since I was studying microsystems. So I also had my own company for fashion tech for over 10 years. And before here, I was working in the field of variable computing. In Berlin, we will have 2 different challenges in the next round. I will present the challenge about the e-textiles, and Robin will follow up with giving some insight about the other challenge, which is about eco-design. So I will start my presentation after that introduction. Okay. So here At Fraunhofer IZM, we conduct research about flexible or textile integrated electronic systems for over 20 years. And the granted artists who will join the next round in Re-FREAM, they of course can benefit from this like large pool of expertise and know-how we developed over the 2 decades. We only have a very, very short time today to present all of our available services and technologies. So I would like to focus mainly on 3 general topics. First of all, we have gained a lot of information about flexible conductive materials. It can be metallized polymer. It can be also like 3D shaped copper film. We can structure here in-house. What we provide to the artist, it's like all this information we have. We usually also select in the beginning of the project some suitable conductive materials. And then after that material selection, we also have the options to electronically and mechanically test and analyze all this material. We can also do this with novel materials we find maybe together or we bring into this project. So we have all these analyzing options to understand the performance of the material. Once a material is selected, we can structure this to like a flexible or textile integrated PCB. Therefore, we can take advantage of like well-known conventional PCB manufacturing techniques or textile processes like embroidery or knitting. But what's also very unique, if you work with us, you will have access to some new developments made here at IZM. And these are soft PCBs based on thermoplastic materials. There we'll have one big advantage. You can produce the thermoplastic PCB on a rigid carrier. At the final step, you lift it off and you laminate everything on your textile substrate. Then what maybe also everyone knows, hardware is hard. Or let's say it's mostly difficult to develop. For this reason, we develop our own hardware kit, especially made for e-textiles in this project. And it will be very similar to the well-known Adafruit or Lillipad kit you maybe know already. Our models will differ in terms of additional interconnection options. So beside soldering or embroidering an electrical connection, we also have the option to bond the module directly on the textile integrated PCB, which makes it really easy for interconnection and also more reliable in long-term stability. Then you maybe ask what kind of models will be available. So at the moment we develop standard modules, which consist of a microcontroller, like an analog digital converter, temperature sensors, or even some actors like LEDs. But the kit can also be customized once we know about your application and we consult in a workshop about the hardware. And last but not least, the integration and interconnection technologies. This is the main focus of our institute. So what we can offer is access to the industrial integration and interconnection technologies. By doing so, we can provide not only the miniaturization of electronics and the packaging and assembly, but we can also create a very reliable demonstrator, especially made for like textile characteristics. So it can be washable, it can withstand like bending and folding and even stretching. So that was my short overview. If you have any questions, I'm happy to answer it in the Q&A session.
Okay, thanks, Christian. I guess I will take over from there. The Q&A follows afterwards, I guess. Hello, everybody joining us online. My name is Robin. I'm also from the IZM, but from the Department of Environmental and Reliability Engineering. I'm actually representing Max today, who's mainly responsible for this project in the department. And so my background is actually, I'm a product designer, and within our department, we have a very multidisciplinary team of engineers, but also people working on sustainability and eco-design innovation processes. So what I will also present today from our department side is the tools and methods we use for the co-creation in the eco-design process. I will start my presentation. Just 1 second. So I hope you can see the presentation now. Still loading. Yes, just jumping back. So as I said, we're from the eco-design department, and just to note from the beginning, so our department doesn't really have any technological resources, but the artist who will join us in our team has a budget that he can later on use on technological development, and we will also connect the artist to our in-house technical possibilities and also external possibilities. What we are interested in our challenge is to introduce the artist or to co-create with the artist a sustainable artifact that incorporates or runs through an eco-design process that we developed so far. So with our last teams, we also took all the teams through this process and tried to shape their ideas in sustainable manners. And the following, what I'm going to present is an abstract or a short overview of the tools and technologicals or methods we use in order to create climate-friendly future solutions for fashion. The process that we go through, the eco-design process, basically consists of 4 steps. So we start from together envisioning and talking about what the sustainable goal of the project will be. This will also then follow into a co-definition. So we will support the artist with technological and research about materials and sustainability challenges within their framework. After that, we will go together into the co-research phase, where I will now also present the main methods that we use to together prototype and qualitatively make a qualitative assessment of the environmental concept of the product or the artifact. Exactly. So we, in our team, we prioritize the sustainability challenges and try to make them an active part of the final result. And we will also support the artist then eventually when it comes down to the prototyping phase, as I said earlier, with technological support. And if we can't deliver it within our department, we will connect the artist in-house within the EZM to other departments. One of our tools that we use to assess what are the pain points within the product or the artifact is the eco wheel, which analyzes the 6 stages that the product or the concept has to run through within its lifetime. And in this stage, we try to make qualitative environmental assessment of the idea, which will then later on be mapped in the Planetary Design Circle. This is a UX tool, which maybe as a comment to an earlier question was also reshaped within the times of co-creation within Corona. So this was a tool that worked quite well, even remotely. So we could support the artists within a co-creation remote brainstorm session. This UX design tool helps to summarize and balance all stakeholders. This is also a big part of our tools that we use. We try to make stakeholder workshops, and eventually, before entering these stakeholder workshops, present all possible challenges that could result from the product or the product process, and try to align them also with the environmental goals. And this is also the last tool that I'm presenting. So the stakeholder workshops, for example, now with Jessica, was one big part of our process that we went through, because in her project, a lot of different stakeholders were involved. And we tried to, in advance, find solutions for possible problems, and also trying to co-develop the product with the stakeholders already in the beginning. So this was also important for us, involving not only the artist, but also the envisioned area that the artist wants to enter with this product already in a practical approach. Yeah, so this from my side, this is just a short overview, just to remember that the technical budget within our team can also be used for other competencies that we have in-house in the EZM. And if you have further questions, I'm also happy to answer them in the Q&A.
Thanks, Robin. Thanks, Christian, for the nice overview what you can offer to our second call artists. Again, we are in the Q&A part, and the final one, so to say. We're open to answer all your questions. Please use the Q&A option, respectively the chat function, for asking questions, and we are happy to answer it. Maybe in the meanwhile, since this maybe is one of the obvious things and can be addressed by multiple hubs, is the question on the printed electronic side with the washability. Christian, maybe some words to that. What's your best experience so far, or some recommendations, considering here some project ideas?
For printed electronics, I think it's very challenging to receive a washability. This is mainly due to the availability of decent pastes or inks. When it comes to washability, we prefer different material options, and that's also what we mainly work with. So like conductive textiles or meander shaped and structured copper films. Nonetheless, we have some experience with printed electronics. We also have a new colleague here who develops own paste, which looks very promising. But when you want to take something commercially available, it's getting really difficult to achieve a really washability after international standards for household washing.
Thanks.
But this is also what I mentioned before. There are so many different materials available, and especially for the selection of a suitable conductor material, you really have to understand the application, and you have to understand also the implementation of the conductor into the objects. So that is something I can give a big overview about all the options, but most likely it will be something we discuss in the beginning with the artist, what we recommend or what experience they maybe had with certain materials before. So there are.
Thank you, Christian.
Yeah.
Maybe Robin, can you elaborate a little bit on your best practice so far together with artists? Tell us some inside story, please.
Yeah, sure. So I think, well, just because it was the most recent one to end with Team Alma, I think it was a good collaboration experience also together with Christian, because it was really taking the idea of a modular, washable underwear concept and detachability of the electronics and separability of each component that we ideated together in the co-creation phase. Taking that down to the prototype was actually quite a well collaboration, and where you could see that was necessary to on the one side develop the electronical possibilities together with Christian. And as soon as we had always we learned about the possibilities, we could rethink also a little bit the design concept and the design approach. And also what we learned from then is how the project could even be taken further after the initial prototype. And I think that was a strong collaboration between first ideating what is possible, trying out then in the laboratory, and then rethinking the design, and also thinking about really very practical approaches then in the end, how to make separability of components possible, and how that affects then eventually also the user experience and the use case eventually.
Thank you, Robin. May I have also then some, let's say, insight experience so far from a technological side from you, Kamina? What was the most impressive thing, to your opinion, technological-wise, that happened together with the artists so far? Can you elaborate here a little on your personal experience?
Well, I think that one of the what we have been working with artists, we have worked with two. With Elizabeth, really, it's a pity that all the COVID problem happens in between, so it was a little bit stopped, all the research. But with her, I think from our side, what was very interesting is all the collaboration also with the 3D printing. I think that this is a thing that must be explored. But really what has been a big success is with Fabio Molina project. He started with the idea of the leather, a similar product of leather with the cork, but made in like in fabric way, no? And we were suggesting, what do you think if we try to nebulize, to apply to garments also the cork as a substrate, so we can have second quality garments, maybe to make them again reused, or garments that are not fashionable anymore. So he found this very interesting, and from only one way of working, now he has three ways of applying the cork, and really the results were fantastic, because we achieve a very innovative material to apply on garments, and also we apply color to the cork. So we had a very new finishing, and now he has a label, and he's going to have his own company through this starting. So I think that is a big success.
Thanks, Carmine, for the nice insight. May I also ask the same question to Naomi? What is the best experience so far within the Re-FREAM? What was the most exciting thing from your side, from a technological perspective, during the course of the first call?
I think that both projects that we are executing are as exciting for us, and also demonstrate a beautiful case for 3D printing on textiles. It was beautiful to work with two very talented artists, designers, very strongly driven, very collaborative, very devoted, and I think it's beautiful how they knew to pick the fruits and the cherries from each partner, and to be able to combine all the qualities that all the different partners offer. So one has to understand that collaboration is not working with a single company. Yes, one single company will focus on the core technology that the designer used, but each partner contributed to the collaborative and the holistic solution. So if it is by software, by thinking process, by conceptualizing, by mechanical solutions, engineering solutions, exposure to alternative solutions, even if these other solutions are not necessarily the ones that are picked to be the final, the enrichment of having so many tools also finally makes the final choice of the single tool tenfold stronger. So one has to understand that the artists and designers are brought into a strong pool of experts and become enhanced through this collaboration. As earlier said, as a teaser, I advise joining the presentations in Ars Electronica in the coming days to see the full results, which we are prohibited from sharing here today, but recommend to be seen.
Thank you, Naomi. Since questions are hardly coming in and we are approaching the end of the session quite soon, I would say let's give us all 5 additional minutes before we close. So to the attendees, please be aware of that for asking further questions if you like. Otherwise, we will close soon our webinar. Maybe some sentences to the end from all our panelists. I would start in the round. Guillaume, what you have some last words to the session?
Yeah, as I look back for the first call and looking forward for the next call, I would say that's already at the midterm meeting that we had in Madrid in January. I was already very much amazed by all the projects that were here already, to see what all the artists had managed to achieve in 4 to 5 months. And the final results, I don't have now. In a few days, I will have the overview of all the artists, but it was really exciting and amazing to see everything that it could create, like new processes, new materials, and new products, which was just, yeah, smashing the limits that we thought we had before. So if we can be a part of it, that's very exciting. If we can help it going forward, yes, I am 100% in. I am really exciting and can't wait to see the applications from the next call, to see what we can help and what visions, what the future of fashion we can have the part to play in.
Thanks, Guillaume. Luca, Oscar from iTech side. Some last words, respectively. What are your best practice experiences so far within the Re-FREAM project and together with the artists? Give us some insights.
Yes, I think with the collaboration in the first call is very profitable. Collaborate with 4 different artists in different items. From, for example, recycled material to new product and new fibers. So a very lot of different material and using different technology. So I think it's a good experience. Maybe I'm sure for a technician also, because introduce other point of view of the use of this technology in more artist and more designer application, I think.
Thank you, Luca. Agnes, some last words from your side regarding the session, respectively best practice and good experience so far together with the artists.
Maybe I would like to mention something what I'm looking forward to for the next call to happen. We have been discussing quite a lot how the thermoregulation or human factor can be integrated or connected to different technologies that have been here presented. And I think 3D printing with these hairy structures or any kind of structures is a kind of very amazing way to create air layers that have great impact on human thermoregulation. So here is actually a big playground how one can do something creative, also commercial, most probably, by connecting our technologies of simulating human being and thermal processes in the clothing with 3D structures that can be applied on top of the clothing. This has been mentioned in few projects in the past, but nobody ever had a time, courage, or ideas how to do that. So I'm looking forward to the projects that will be wanting to do this.
Thanks, Agnes, and good point to look for the second call. And we are all awaiting your application by end of the month to have a look on it. So with this, I think we can come to an end. Maybe some last words also from my side. I can only repeat of all the panelists so far, so there would be nothing new besides what was already said. Looking forward to your application. If you have further questions or after the session you come up, maybe I should have asked, please refer to the help desk on the Re-FREAM webpage. They will forward us the questions and we are happy to answer also that. Until then, thank you for joining and see your application soon. And thanks all to the panelists in providing the information to you, and see you hopefully soon. Bye.
Thank you. Bye.
Ciao.
Thanks for attending. Bye.
Bye.